Today we're doing the first set of notes in the exponential chapter, and we're going to talk about graphing. So your exponential functions will always follow the model of f of x equals a times b raised to the x power. A is going to be a coefficient. B is going to be considered your base. Up to this point, our exponents would always be numerical values. Now the variable is going to be in the exponent spot. So for the first problem, we have 3 times 2 raised to the x power. Again, if you're using Desmos, feel free to go in to Desmos graphing calculator and type this equation. You'll just have to hover your mouse over the coordinates that you see, or you could use a calculator and plug it in. So I paused the video and inputted all of this. So your graph should look something to this effect. It shouldn't be as curvy there. I don't know what happened when I was connecting my dots. So as far as the domain and range goes, so domain will still go left to right. My domain is still going to be negative infinity, like negative infinity to positive infinity, like it has been for most of the chapters. The range, however, we will see something new happening here. So you're going to notice on the graph that it's leveling out at a horizontal value. So this graph is leveling out at this horizontal value of 0. So my range is going to be from 0 to infinity. Notice I put a parenthesis there because my graph will never actually touch 0. You can keep moving your graph to the left, or you can put more x values in, and you're going to notice that all of those matching y values will get very, very close to 0. But we'll never go past 0. Also, some other patterns you should notice that my base was 2, and you're going to notice that each one of these values, every time it grew, it multiplied by 2. So that's also kind of the pattern that you should notice there. Some other things, so again, I kind of just elaborated on that. Your base is going to be your multiplier. So if your base is 3, that means your y value should be multiplying by 3 in the way they grow. Your A is always going to be your y-intercept. Asymptote is the new vocabulary word that we're going to introduce. So asymptote is the horizontal line at which the graph levels out at. Exponential growth, your base will always be greater than 1. Exponential decay, your base will always be between 0 and 1. Your base can never be equal to 1 because then you won't have an exponential equation. 1 raised to any number will always equal 1. Exponential decay, I think, got cut off and is on the next page. So as far as looking at graphs, we always read graphs left to right. So letter A would be an example of exponential decay. It's going down over time, whereas letter B is growth because it is growing over time. Some applicable scenarios for exponential growth, for example, COVID would be an exponential growth. It grows very quickly, it spreads very fastly. Same thing as like the idea of a secret. You tell one person a secret, and then that one person tells 2 people, and then it just kind of spreads like wildfire. C, D, and E, when you are looking at the equations and not the graph, you look at your base. So 4 is my base, and because it's larger than 1, this would be growth. D will be decay because my base is less than 1. And E would also be decay because my base is less than 1. All 5 of them will have an asymptote at y equals 0 because there is nothing written out on the right-hand side. Like there's nothing written there. So go ahead and try the practice problem below. So after you do that practice problem, you'll probably just want to go ahead and hit pause so that you can copy these y values down. Again, you would practice using the Desmos graphing calculator to obtain these y values, or if you're doing it by hand, you would, for example, if we did this one, you would type -2 times 1.5 raised to the -1. So that's how you would type it in a calculator. If you're using your cell phone, it's not as user-friendly. I would recommend you using Desmos instead, but on the graphing or on your cell phones, you should see a button that looks like this, and that will allow you to type a number first and raise it to a power second. So here, if I were to flip this equation up, this would be an example of growth. So there's two ways to know this. My base is larger than 1, it's 1.5, so that's one way to know it. And again, if I were to reflect this back over the x-axis, it would look something like that, and that would be growth. The domain is still going to be negative infinity to infinity. That will always be your domain. It's the range that you have to think about. Notice for this one, all my y values are negative. So my range is negative infinity, and this time it stops at 0. As far as the effect it had on the graph, the a value, the negative a value, reflects over the x-axis. Again, right below this, you have 4 practice problems. They're asking you to match them without using a calculator based on your idea of growth versus decay. Some other values to look for. Notice your a value is always going to be your y-intercept. So for this problem, my a value is -2, and notice it crossed my graph at -2. So that's a little hint for that next section. Horizontal shifts. Your k value is always going to shift your graph up or down. Again, I'm never going to make you do this without a calculator, but it's good just to have a general understanding on how these work. So here, because there's a -1 on the outside, that has shifted my graph down 1 unit. My domain will still be negative infinity to infinity, because it'll grow forever. My range, though, is now -1 to infinity, and it's -1 because my graph is leveling out this time at -1. The asymptote of the function is at y equals -1, and the k value shifted me down 1 unit. As far as our vertical shifts, our h value is going to shift us left and right, and I think I had these words wrong. On your paper, this is your horizontal shifts. This one is the vertical shifts. My apologies. Your h value is going to shift you left and right. These are a little bit more difficult to spot. So looking at this graph, my domain is negative infinity to infinity. My range will be 0 to infinity because my graph is leveling out at y equals 0. The only way I can really tell that this graph has shifted left or right is the fact that I know my a value is supposed to be my y-intercept. So 3 is where it's supposed to be crossing the y-axis. And if you compare it to where the y-axis is, notice it has shifted to the right by 1 unit. So notice your h value goes opposite. If it's -1, that shifted to the right one. If it would say x plus 1, that means it shifts us to the left one. And that, I think, will be all. You have one more practice section of matching, and again, a pop-up will appear for that last part.